Alright, let's determine the intervals of concavity and the points of inflection for the following function. F of x is equal to x to the power of 4 plus 4x cubed minus 18x squared plus 12x minus 12. Okay, so if we want to determine our points of concavity, we need to apply the second derivative test. So I'm going to find the first derivative. F prime of x here is equal to 4x cubed. So I'm using a combination of power rule and sum and difference rule. And so just kind of review the derivative rules if you don't understand what I'm doing. Plus 12x squared minus 36x plus 12. Okay, so that's our first derivative. To use the second derivative test to find intervals of concavity, I need to find the derivative of the first derivative. So you get 12x squared plus 24x minus 36. Okay. So we want to find the intervals of concavity and the points of inflection. So to find the point of inflection, a point of inflection will occur when the second derivative is equal to 0. So I need to equate my second derivative function to 0. So 12x squared plus 24x minus 36 is equal to 0. I'm going to factor this out. All of these are multiples. These coefficients and constants are multiples of 12. So you have 12x squared plus 2x minus 3 is equal to 0, and then I'm going to factor the inside here. So I have x squared plus 3x minus x minus 3, and then if I factor this out, I get x minus 1 times x plus 3 times 12 on the outside is equal to 0, and then we can see that our point of inflection will occur when these factors are equal to 0, so technically when x is equal to 1 or negative 3. Okay, so these are our points of inflection. Now, using our points of inflection, we want to find the intervals of concavity. So we know according to second derivative test that if f prime of x is greater than 0, the function is going to be concave up. We also know that if f prime of x is less than 0, the graph is going to be concave down. So in this case, I want to use the point of inflection to determine other points, specifically my intervals of concavity. So negative infinity, positive infinity. I'm going to use a number line, and I'm going to plot my points of inflection. So you should have a negative 3 here, and you should have a 1 here. Okay, and let's test out these intervals, right? So I'm going to test out the interval from negative infinity to negative 3. So if I test out this interval, I'm going to pick a value from this interval. Let's say x is equal to negative 4. So if I let x equal to negative 4, I'm going to plug this in to my second derivative function. So I do f double prime of negative 4 is going to give me basically, and I'm going to use the factored form of this, right? 12 times negative 4 minus 1, negative 4 plus 3, and you can see that you get 12 times negative 5 times negative 1. So you can see that this is going to be positive 60, right? So this is greater than or equal to 0, and as a result, right, we know that this is going to be concave up in this interval. Okay, so it's concave up in the interval of negative infinity to negative 3. Then what we're going to do is we're going to test this interval between negative 3 and 1, right? So it's concave up between negative infinity and negative 3. Between negative 3 and 1, I'm going to let x equal 0. So if I do f double prime of 0 in the second derivative function, I get 12 times 0 minus 1, 0 plus 3, and that's going to give me 12 times negative 1 times 3. So that basically gives me negative 36, which is a negative value, right? So it's less than or equal to 0, and as a result, it's concave down. Okay, so it's concave down between negative infinity and negative 3. Sorry, concave up between negative infinity and negative 3, and concave down between negative 3 and 1. And for the last interval, between 1 and positive infinity, let's say I test x is equal to 2. So I'm going to do f double prime of 2, which is basically equal to 12 times 2 minus 1, 2 plus 3, and you basically get 60. Okay, so it's positive, right? It's greater or equal to 0. And as a result, this should be concave up, right? So it's concave up in this interval. So that basically tells us that for our answer here, right, our point of inflection will occur when x is equal to 1 and -3. If you want to find an actual point for this, you can plug it in. So it's going to be f of 1, which is 1 to the power 4 plus 4 1 cubed minus 18 1 squared plus 12 times 1 minus 12. And if we punch this out, we'll basically get 1 plus 4, which is 5, minus 18, so -13, plus 12, which is -1, minus 12 is -13. So one of our points of inflection is 1 and -13, right? And the other point of inflection, if we do f of 3, just going to move this up a little bit. Oops. So to find the other point of inflection, I'm going to do f of -3, and if I plug that into my function, I get -237, right? So just to kind of summarize all of this, I'm just going to make some space here, right? The point of inflections are going to basically be 1 and -13, as well as -3 and 237, -237. And the intervals for concave up are going to basically be between -infinity, when x belongs to -infinity and 3, as well as union 1 and positive infinity. And the intervals for concave down are going to basically be x belongs to -3 and 1. Okay, so that's basically it. That's our answer.